Hey guys, Sully here with Losing Logic. Today we are going to look at a 4x4 matrix that I'm going to be drawing out right now. And with this 4x4 matrix, we are going to only perform elementary row and column operations. So what this means is, even if I get a row of all zeros except for maybe one number, I cannot use cofactor expansion. So I'm going to look for a upper or lower triangular matrix in order to multiply the diagonal and receive the determinant. So first things first, we see, or I saw, that we had a -7 here and a 7 here, followed by a -1 here and a 1 here, as well as a 0 here and a 0 here. So what I then had to figure out was whether to replace row 4 or row 1. And I replaced row 1 because I am contributing to developing a lower triangular matrix, which is zeros on top, by adding this 0 and this 0, as well as including this 0. If I were to do it the other way, I would be adding a 0 here, yes, but this 0 would not be contributing to these 6 numbers having to be turned into a 0. Therefore, I did row 1 plus row 4. And I got the following. I had 4, and then 0, 13, and 0. And these will all be the same values. This will not be changing. Continuing, we now look for potentially simplifying this more. So what I found was, instead of immediately jumping to column simplifications, because we'd be introducing a 7 here in the 0 spot, I wanted to continue with my row simplifications. So by performing an operation here, I can create a 0 without adding or getting rid of a 0 up here. So what I did was 3 times R4 plus R3. And what that does is it turns this into a -3, you add it to 3, and this will become a 0. So we're replacing the third row. Now, continuing, we have the same row 1, the same row 2, and we multiply. This is going to be 0 plus 3 is just 3. 3 times 7 is 21. That'll be plus 6, 27. We have 3 times 4 is 12, plus -3 is 9. We have 3 times -1 is -3, plus 3 is 0, and that's what we wanted to have. And we keep this row the same. Okay, so this is when it gets very hairy, because we go on to, sorry for doing that out of view, we go on to column manipulations, and the only way to really get anything working is to apply something here and here. Because if I were to try to get rid of this 7 somehow, I would be adding or getting rid of a 0 elsewhere. Or, excuse me, I'm essentially starting with 13, because if I were to adjust, well, I guess I could have started with 7. So let's just ignore that. What I did was, I saw that if I multiplied 4 by -13 over 4, it would just be -13 plus 13, which is 0. And then it would not impact any other zeros, so that was a safe bet for being on the right track. So the result was replacing this column with -13 over 4 times C1 plus C3. Now, continuing, we have the following arithmetic to solve. Negative 13 times 4 plus 13 is obviously 0. That's what we were looking for. But then we have negative 13 over 4 times 6 plus 7. And this is when I thought I was on the wrong track. Because this is equal to negative 25 over 2, or negative 12.5. And then if I do negative 13 over 4 times 3 plus 9, we get negative 3/4. So I kind of chugged on. We know that 0 times negative 13 over 4 is just 0. And negative plus 4 will be 4. So the matrix rewritten will be as follows. We 4, 0, 0, 0, 6, 2, negative 25 over 2, 0, 3, 27, negative 3 over 4, 0, 0, 7, 4, negative 1. So this is our new matrix. So where to go from now is, I was kind of like, well, I guess I only have one option. I have a 0 here, so I'm now able to add this column to this column without making this a non-zero value. So I did that by the only way you can, by saying 25 over 4 times column 2 plus column 3. That is the only thing you can do that will maintain the structure of these zeros, as well as making this a 0. So performing the arithmetic, 25 over 4 times 2 minus 25 over 2 is going to be 0. Okay, and then we look over here, we have 25 over 4 times 27 minus 3/4. And you're going to have to trust me on this one. This one is 168. And when I saw this value, I was like, alright, I'm on the right track. Like, that's a whole number. Maybe the guys gave me a whole number to work with. And then I came here. I had 25 over 4 times 7 plus 4. And that's when I got 191 over 4th. So I was back to uncertainty. So now we can rewrite this matrix with our 0 value. So this will become 4, 0, 0, 0, 6, 2, 0, 0, 3, 27, negative 3/4, 0, and this last row will be 0, 7, 4, negative 1. So now we have a lower triangular matrix. We have finally found all the zeros here. So what we do is simply 4 times 2 times, excuse me, I lost, this isn't negative 3/4. Negative 3/4 was the original value, and then we made it 168 here. So this value is actually 168, so we multiply that, 168, and lastly we multiply negative 1, and believe it or not, this is right. The determinant of that 4x4 matrix is negative 1,344. Thanks for watching, and have a good day. Peace.